Okay, so in this video, we will do an example of the adjoint formula in the case of a 3 by 3 matrix. And as you'll see, all you need to do is find for each entry the corresponding cofactor. So we'll start with building the cofactors for the first row. So let's start with C11. We'll get no negative because 1 plus 1 is 2, which is even, times the determinant of the matrix obtained from A after we delete the first row, first column. Delete the first row, first column, and you have the matrix negative 1, 1, 3, 3. You can compute this. This is now the determinant of a 2 by 2 matrix. So all we have to use is AD minus BC. So negative 1 times 3, negative 3, minus 3 times 1, minus 3, that's negative 6. Let's keep going. C1, 2. Here we will have a negative determinant of the 2 by 2 matrix after deleting the first row, second column. First row, second column, and you get the matrix 1, 1, 3, 3. Well, the determinant here will be 3 minus 3, which is 0. Negative 0 is just 0. And we now have C1, 2. And finally, C1, 3. 1 plus 3 is 4, which is even, no negative sign. Determinant of the 2 by 2 matrix obtained after we delete the first row, third column. First row, third column, we get 1, negative 1, 3, 3. The determinant here will be 1 times 3, 3, minus negative 3. 3 negative negative 3 is 3 plus 3, which is 6. And there you go, we're a third of the way done. We have 3 cofactors. There are 6 cofactors missing. Let's keep going. Let's find the cofactors for the second row. So C2, 1. 2 plus 1 is 3, which is odd. We get a negative. Determinant after we delete now row 2, column 1. Deleting row 2, column 1 gives the matrix 0, 1, 3, 3. The determinant will be 0 minus 3. So negative 3 for the matrix. Negative of that gives us positive 3. Then C2, 2. 2 plus 2 is even, no negative sign. We now delete row 2, column 2. So row 2, column 2 gives you 2, 1, 3, 3. Determinant is 2 times 3, 6, minus 3 times 3, 3. 6 minus 3, positive 3. And finally, C2, 3. 2 plus 3 is 5, which is odd. We do get a negative. Now we delete row 2, column 3. Delete row 2, column 3. And you get the matrix 2, 0, 3, 3. The determinant is 6 minus 0, which is 6. But there's a negative in front, so we get negative 6. Now we're 2/3 of the way done. We're missing the cofactors for the third and final row. So C3, 1. 3 plus 1 is 4, which is even, so no negative sign. The determinant of the 2 by 2 matrix after we delete the third row, first column. Third row, first column, you get 0, 1, negative 1, 1. The determinant of this will be 0 minus negative 1, so it's positive 1. C3, 2. 3 plus 2 is 5, which is odd. We do get a negative sign in this case. We now delete row 3, column 2. Row 3, column 2, and you get the matrix 2, 1, 1, 1. The determinant is 2 minus 1, which is 1. Negative of that, negative 1. And finally, C3, 3. 3 plus 3 is 6, which is even, no negative sign. Determinant of A after we delete the third row, third column. Third row, third column, 2, 0, 1, negative 1. We get 2 times negative 1, negative 2, minus 0, hence negative 2. Now we have all 9 cofactors, and now we can find the determinant of A quite simply by using cofactor expansion along any row or column of our choice, because we already have found all 9 cofactors. Let's use row 1. So this would be A11 times its cofactor, plus A12 times its cofactor, plus A13 times its cofactor. So we have used cofactor expansion along the first row, and now we have everything. A11 is 2 times C11, which is negative 6. So 2 times negative 6 is negative 12. Plus A12 times C22. Well, A12 happens to be 0 times 0. That's kind of funny, but that's 0. Plus A13 times C13. Well, A13 is 1 times C13, which is 6. 1 times 6 is 6. And all we have in the end is negative 6. And now we have the determinant of A. And we're done. We have the inverse now, right? So let's write our final answer. From the adjoint formula, A inverse is 1 over the determinant, negative 6, times the adjoint formula. And if you remember, the adjoint formula is the cofactor matrix transposed. So if you look, this is the entry A11. We replace this by its cofactor C11. This is the entry A12 replaced by C12. And this is the entry A13 replaced by its cofactor C13, which is 6. Let's keep going. This is A21 replaced by its cofactor, which is 3. This is A22, this is A22 replaced by its cofactor, which is 3. And finally, this is A23 replaced by its cofactor C23, and that's negative 6. Finally, the third row, this is A31 replaced by C31, which is 1. This is this is A32 replaced by its cofactor C32, which is negative 1. And this is A33 replaced by its cofactor C33, which is negative 2. And now let's transpose. So here we'll write this as negative 1 over 6. Well, if you transpose, the rows become columns and vice versa. So the first row, negative 6, 0, 6, becomes the first column, negative 6, 0, 6. The second row becomes the second column, hence 3, 3, negative 6. And finally, the third row becomes the third column, 1, negative 1, negative 2. And there you have it. The inverse of this 3 by 3 matrix is this 3 by 3 matrix. And leave the negative 1 over 6 out as a scalar multiple, because not every number here is divisible by 6, so you'll just introduce several fractions. So leave it up front. And this is how you use the adjoint formula. You could also check if you wanted to by finding the inverse of A using row reduction. Right? You would augment A with I, row reduce, and A will be reduced to I, and I will actually become A inverse. Or you can also check your result by simply multiplying A inverse times A, and making sure, of course, the result is equal to I.